Good morning, students. Welcome to our physics class. In the previous class, we discussed dispersion by a glass prism. What is dispersion? Dispersion is the splitting of sunlight into 7 colors when it passes through a glass prism. What are the 7 colors? Violet, indigo, blue, green, yellow, orange and red. Okay, so in today's class we have to discuss an experiment by Isaac Newton. We know Isaac Newton is a scientist. Okay, we already studied some concepts related with Isaac Newton, motion, laws of motion, etc. Okay, so Isaac Newton is the first scientist to explain. He explained the concept of dispersion of light. Okay, what is the dispersion of light? Splitting of white light into 7 colors. First, he explained the dispersion using a glass prism. First, he explained dispersion of light. What is the dispersion of light? It is the splitting of white light into 7 colors. So, this is violet, indigo, blue, green, yellow, orange and red. Next, he placed an identical prism in an inverted position. Isaac Newton placed another identical prism in inverted position near the first prism. Okay, so this light these 7 colors are combined to form white light. So in the Isaac Newton's experiment, first he explained the formation of 7 colors by a glass prism. Then he placed same identical prism in an inverted position near the first. Then he allowed to pass these 7 colors through the second inverted prism. Okay, then his conclusion was white light is formed in the screen. So first he explained the dispersion, splitting of white light into 7 colors. Then he combined these 7 colors into white light using another identical prism placed in an inverted position. Okay, this is the experiment done by Sir Isaac Newton. Okay, so in the first case, in the first prism, this white light split into 7 colors. They are called Weber. Violet, indigo, blue, green, yellow, orange and red. Okay, then he explained the combination of these 7 colors into white light. So the combination of these 7 colors is called white light. White light. So Sir Isaac Newton explained the combination of 7 colors are formed white light. Clear? Okay. So which is the most deviated color? Most deviated color is violet, least deviated color is red, and all other colors lies in between violet and red. Okay, then using another identical prism placed in an inverted position, Sir Isaac Newton explained the combination of these 7 colors to form white color. This white light is called visible light or sunlight. Okay, next we have to discuss the application of the dispersion. The application of the dispersion is the formation of rainbow. Formation of rainbow. We know what is the meaning of rainbow? Okay, rainbow is formed after the rain shower. We know where rainbow is formed. At the morning, rainbow is formed opposite to the sun. At the morning, where is the position of the sun? Position of the sun at the morning is east. So rainbow is formed in the west. At the evening, the position of the sun is at the west. So rainbow is formed at the east in the evening. So rainbow is always formed in the direction of opposite to the sun. The direction of opposite to the sun. Then rainbow is always formed after the rain shower. After the rain shower, rainbow is formed in the atmosphere. Okay, we know in the atmosphere there are many water droplets after the rain shower. After the rain shower, there are many water droplets in the atmosphere. Each water droplets act as tiny prisms. We know about a prism. When sunlight passes through a prism, it is split into 7 colors. These 7 colors are called vibgyor. Okay, so what are the colors included in a rainbow? 7 colors are included in a rainbow. Okay, so this point is called center of the rainbow. So 7 colors are formed. Wow. What are the 7 colors? This is red, violet, indigo, blue, green, yellow, orange and red. 7 colors are formed in the rainbow. What is the shape of the rainbow? Bow shape. Okay, that's why it is called rainbow. The shape of the rainbow is bow shape. That's why it is called rainbow. When rainbow is formed? Rainbow is formed after the rain shower. Where rainbow is formed? Rainbow is formed in the atmosphere. Okay, rainbow is formed in the atmosphere after the rain shower. Rainbow is always formed opposite to the direction of the or opposite to the position of the sun. Okay, at the morning rainbow is formed at the west. At the evening rainbow is formed at the east. Clear? So when light falls on a water drops in the atmosphere after the rain shower, there are many water droplets in the atmosphere. Okay, for example, we consider a water drop. We consider a small water droplet in the atmosphere. So the sunlight from the sun falls on these water drops. It undergoes refraction. It undergoes refraction. Then it undergoes internal reflection. This phenomenon is called internal reflection. Then it comes out from this water drop. So here 7 colors are formed. This is the rainbow. Okay, so what are the phenomenons included in the formation of rainbow? First, sunlight falls on a water drop. This is water drop. First, sunlight falls on the water drop. Then it undergoes refraction. Why it undergoes refraction? What is refraction? Refraction is the bending of light when it travels from one medium to another medium. So here medium is air. Okay, air is the rarer medium. So here medium is water, rarer medium to denser medium. So there is a bending towards the normal. This phenomenon is called refraction of light. When sunlight falls on a water drop, it undergoes refraction. Okay, then inside the water drop, light undergoes internal reflection. Here internal reflection. It undergoes internal reflection. Then another refraction. At the same time, it is split into 7 colors. So what are the phenomena included in the formation of rainbow? First, two refraction. One internal reflection, then dispersion. These are the phenomena included in the formation of rainbow. So when sunlight falls on a water droplet, it undergoes two refraction. One air to water and water to air is the second. Next, one internal reflection. Here this light ray is reflected internally. Okay, or reflection takes place inside the water drop, that is called internal reflection. Then it undergoes dispersion, thus it is split into 7 colors. Okay, this is the formation of rainbow. So which color, so in the formation of rainbow, which color is the outer of the rainbow? Which color is formed? Red. Inner color is violet, outer color is red. The shape of the rainbow is bow shape. So this is the formation of rainbow. What are the points? First, rainbow is formed in the atmosphere after the rain shower. Okay, after the rain shower, there are many water droplets in the atmosphere. Each water droplets appears acts like tiny prisms. Okay, from each water drops 7 colors are formed. Okay, separate colors are formed in groups. Okay, all violet colors are grouped together, all red colors are grouped together, Okay, all other colors are in between these violet and red. Okay, each color makes different angles with the line of vision of the observer. If we observe a rainbow, okay, this line is called line of vision. Okay, violet color makes one angle with a line of vision. Okay, red color makes another angle with a line of vision. So these angles are different. Okay, so these angles are different with the line of vision. So this rainbow appears like a bow. So it is called a rainbow. Rainbow is always formed opposite to the position of the sun. Okay, in the formation of rainbow, it undergoes three processes. First process is two refraction. Second is one internal reflection. Third is dispersion. Thus, a rainbow is formed. This is the formation of rainbow. Formation of the rainbow is the application of the dispersion of the light. Clear? So now we discussed two concepts. First concept is one experiment done by Sir Isaac Newton. Okay, Isaac Newton explained firstly the formation of 7 colors using one prism. Okay, then he placed another identical prism in an inverted position near the first prism, and he allowed to pass these 7 colors through the second prism. Thus he formed white light in the screen. So we can say that white light passes through a prism split into 7 colors. When these 7 colors are passed through another prism, white light is formed. Clear? Next is the application of the dispersion is rainbow. Okay, we explained rainbow as in detail. Okay. Next topic is atmospheric refraction. Atmospheric refraction. We know about what is refraction. Refraction is the bending of light when it travels from one medium to another medium. In the case of atmosphere, there is two mediums. What are the two mediums? Hot air and cold air. We know in the case of hot air is less dense, low density. Colder air, high density. Okay, so hot air is the rarer medium. Colder air is the denser medium. When light passes through the different layers of the atmosphere, light undergoes refraction. That refraction is called atmospheric refraction, or the refraction takes place in the Earth's atmosphere is called atmospheric refraction. Okay, due to atmospheric refraction, there are many interesting phenomena. The first phenomenon is twinkling of stars. Twinkling of stars. Now, we know about stars. Okay, in the stars, light is formed due to the nuclear fusion of hydrogen atoms. The stars, including sun. Okay, there are many hydrogen atoms. These hydrogen atoms are combined to form helium. Thus, light is formed in the star. Okay, light is the light coming from the stars reaches the earth. Okay, passing through different layers of the atmosphere. Okay, thus there are many layers, or there are hotter air and colder air, In the case of colder air means high dense, hotter air means low dense. When the light from the stars passes through these colder or hotter airs, it undergoes deviations. Thus, it fluctuates. Thus, we can say the twinkling of stars. Sometimes we get bright light. Okay, sometimes light coming from stars, sometimes brighter, sometimes fainter. Okay, so we can say it the twinkling of stars. So twinkling of stars is the application of the atmospheric refraction. What is atmospheric refraction? The refraction takes place in the atmosphere of the earth is called atmospheric refraction. The light coming from the star passes through the different layers of the atmosphere and it reaches our eyes. Sometimes it is brighter, sometimes it is fainter. That's why we can say stars are twinkling. Stars are twinkling. We can consider stars as a point-sized object. Why? Stars are very far away from us. That's why we can say it is point-sized objects. The light coming from the stars, sometimes it is brighter, sometimes it is fainter. That's why we see twinkling of stars. Stars are actually not twinkling, but this twinkling of star is due to the atmospheric refraction of light. Okay, another application of the atmospheric refraction is advanced sunrise and delayed sunset. What is the meaning of advanced sunrise? We can see the sun before actual sunrise. What? Before actual sunrise, we can see sun. That is called advanced sunrise. For example, here is the earth. This line is called horizon. This line is called horizon. Okay, so if here is the sun, we can say sunset. Sunset means sun is where is the sun? Sun is below the horizon. We can say it is called sunset. Okay, if sun is above the horizon, we can say sunrise. Okay, so before 2 minutes of actual sunrise, before the 2 minutes of actual sunrise, we can see the sun. That is called advanced sunrise. So here is one, he is looking the sun. So the actual position of the sun is below the horizon, but before the actual sunrise of 2 minutes, we can see the sun. That is due to the atmospheric refraction. Due to atmospheric refraction, we can see the sun before actual sunrise. Okay, so what is delayed sunset? Delayed sunset, what is the meaning of sunset? Sunset means the sun is below the horizon. That is called sunset. After the sunset, we can see 2 minutes. We can see the sun 2 minutes after the sunset. That is phenomenon is called delayed sunset. This advanced sunrise and delayed sunset is the application of the atmospheric refraction. Clear? What is atmospheric refraction? The refraction takes place at the Earth's atmosphere is called atmospheric refraction. Before actual sunrise, we can see the sun 2 minutes before the actual sunrise. We can see the sun 2 minutes after the sunset. This phenomenon is called advanced sunrise and delayed sunset. These two are the application of the atmospheric refraction. Okay, so today we discussed the formation of the rainbow. Okay, rainbow is formed in the atmosphere after the rain shower. It undergoes two refraction, one internal reflection and dispersion to form rainbow. The shape of the rainbow is bow shape. Why rainbow is in bow shape? Each color makes different angles with the line of vision. Okay, then next is the atmospheric refraction. The applications of the atmospheric refraction. Number one, twinkling of stars. Stars are actually twinkling? No, stars are not twinkling, but we feel the twinkling of stars. Why? Due to atmospheric refraction of light. Sometimes the light coming from stars brighter, sometimes it fainter. Okay, stars are very far away from us. That's why due to atmospheric refraction we feel twinkling of stars. Next application is advanced sunrise and delayed sunset. What is advanced sunrise? We can see the sun before actual sunrise, 2 minutes before actual sunrise, 2 minutes after sunset. That is called advanced sunrise and delayed sunset. So the time difference between advanced sunrise and actual sunrise is 2 minutes. The time difference between actual sunset and delayed sunset is also 2 minutes. Clear? So these are the applications of atmospheric refraction. So today we can conclude our class. Okay, thank you.